Everyone, Andre here, and this is my computer science project for 2014 in .4. So what I have right here is an Arduino DUE microcontroller. This is a 32-bit ARM microcontroller. And what I have it doing right now is I have it hooked up to two RC gimbals, which are two sets of potentiometers which allow us to potentially control a vehicle. We have, of course, these four analog lines being read by the DUE. We also have an I2C display, which right now is just saying hello world, but will soon hold a menu interface. The whole point of this project, of course, being that I will create my own RC remote, which will enable me to talk to any standard PPM or S-Bus receiver, and add a whole bunch of features as time goes on. So, of course, I have these gimbals, as I said, the display, and then the last thing here, this thing here, is a probe from my oscilloscope. So what I have here is I have it hooked up to ground and pin 2 on the DUE. And what the DUE is currently doing is it's taking these four channels from the two gimbals and outputting those along with a total of 16 channels of what is called PPM, or pulse position modulation. Now, what pulse position modulation is, if you had a normal PWM, actually I can Google a PWM output right now to show you a picture. We can look at what PWM looks like. So here we go. This would be a PWM signal. So we have, actually this is probably a better example. So here we have one channel per wire. So this wire would pulse at, in this case, 191 out of 255. This would be a 255. So if it was completely on, it would be this, and this would be it being pulsed, and this would read a value. If you could read this value as 191 with another microcontroller. Now, the problem with this is that while this is fine and dandy for outputs, it's very pin costly, and to get the 16 channels that I would need, you'd have to use 16 PWM pins, which the DUE doesn't actually have. So a way to get around this is use something called PPM, and what PPM is that it takes basically as many channels as you want, in this case 16, which is the most that are really used in the industry currently, and squeezes all of them into one channel. And I'm going to show you what it looks like with the oscilloscope output here. So this is the live oscilloscope output from the DUE here. So what we see here is that this very big break here, this very large on state here, is actually the divider, basically the line return for the signal. The signal itself is between these big breaks here. And these, you'll count between those, there's exactly 16 lines, 16 rectangle type things here. And those are our channels. So right now, we have this value to the max. So the second value is going to be as large as it gets. Now, watch the very first value after the big one. Now I'm going to put it to minimum, and we see that it's just got a lot smaller. If we look at the Arduino code I have, and we open up the serial monitor, we can interlace these two values with the throttle signal. So right now we have the throttle signal at the very minimum, and again, watch the very first one. I'm going to put it to as high as it gets, to 2300, and now that line just became a lot bigger. Okay? And the same can be said about the pitch value, which is the third one, which now got bigger and smaller. And the same goes for the other two channels. Now, we have all these channels here, of course, which are the same size right now. And that's because those are channels that I'm not currently using. They are in the ADC's default state. The way that my radio receiver works is that it's going to read this PPM signal natively, and it's going to be expecting 16 channels. So all these channels, even though they're default state, are simply going to not appear in my final output. Now, just to demonstrate that my code works, of course, what I'm going to do is I'm going to go ahead and scroll through my code here to where I'm selecting the number of channels. So we currently have 16 channels. I'm going to select, let's say, 4 channels, which are the very basic of what I need. We're going to close this so that it actually uploads, and we're going to hit upload. So now this, of course, stops. The Arduino compiles, which is going to take a little bit as it checks the memory, and we should see that now we only have 4 actual channels. Okay, so now it resets, and any second now. There we go. So now we only have 4 actual channels, with this being a division in time. So this is the maximum. Watch the first line again. This is the maximum value of the throttle. Now I put it to minimum, and we see that that just got a lot smaller. So this is a what we call a standard PPM value. Now my code actually has built-in support for inverted PPM as well, which is sometimes used by certain receivers. So what we can do is we just comment out that line, and we uncomment that register line. Okay, now we upload again. Of course, this goes dark again. And we're able to change the pin that it's on, obviously, the number of channels, inverted output versus normal output, as well as the division between them, the time division. So now we can see this is inverted PPM output, so the line break is now lower, and then what we can look at as the value is actually the space between these the rising edges. So right now it's minimum. If I put it to maximum on the first channel, that just increased there. So that would be inverted PPM output. Anyway, so this is the basic overview of what I have so far. I hope you enjoy it. So far it's about 500 lines of code to generate the signal, and soon I'll be adding a lot more features that will actually mess with these values and do things like exponential increase of the throttle, so you'll have it so that, you know, if you're going a quarter way through the throttle, it might actually do half in the signal. It's a lot of things that you want to do on aircraft. So I hope you enjoyed the video, and I will have more updates soon. Thank you.